Assalamualaikum warahmatullahi wabarakatuh. Today our group will present about the investigation of voltage collapse incident in Sri Lankan power system network based on article that we found. So our group member consists of Muhammad Danish Arham, Muhammad HAFIZI bin Muhammad DAID, and me, Muhammad NURAQMAL bin Muhammad SHARIFF. So the introduction for the investigation is the Western System Coordination Council, which is WSCC, interconnected transmission system in North America, experienced a significant disturbance on July 2, 1996, causing a widespread interruption of electrical service to approximately 2 million customers. In a similar time frame, the Malaysian power system also faced a disturbance that took several hours to restore. This incident highlights the importance of addressing voltage instability, which poses a threat to power system operation in both developing and mature networks. Understanding voltage stability is crucial for ensuring system security and reliability. This paper aims to investigate voltage stability issues by utilizing static and dynamic analysis methods, such as continuation power flow and eigenvalues analysis. By examining past incidents and their causes, valuable insight can be gained to prevent future occurrence and enhance power system stability. So, we will explain the protection system involved in this accident and its operation and how it relates to the incidents.
Okay. For the event background and system, the condition for the first condition is the incident in Sri Lankan power system on May 2, 1995 involved a tripping of HAFIZI Biagama 220 kV lines, which result in a major blackout. The protection system employed in this incident was distant relay protection. Before the incident, the power system was operating in a steady state, supplying a peak demand of 981 megawatt, and the cold mail via gamma lines were responsible for transporting about 500 megawatt of power to the Colombo area. However, a lightning strike occurred approximately 26 kilo from Biagama, causing one of the lines to trip due to the operation of the distant relay protection. Subsequently, the second line also tripping within seconds due to distance relay operation. The tripping of both lines led to a deficit of around 500 megawatt power in Colombo area, triggering a cascade effect that result in a total blackout around 6:55 p.m. and restoration efforts were made and the system was brought back online by 8:33 p.m. The incident highlight the reliance of Kotmel Biaga lines for power transfer in the Sri Lankan power system. The tripping of these lines due to the operation of distance relay protection caused a significant power deficit and subsequent blackout. The total estimate from the accident was approximately 851.9 megawatt hour. This incident emphasized the critical role of protection system in detecting and isolating fault to prevent further damage and ensure the reliable operation of power system. It also underscored the need of robust and effective protection scheme to minimize the impact of such incident on power supply and to facilitate timely restoration efforts.
And as you can see, this is some data from the incident. As you can see, from the table 1, the ranking of weak buses at the initial loading. And the second table, weak buses at the collapse point for the intake case. The third table is ranking of weak buses with one line outage or normal load. Another one next, ranking of weak buses with one line outage, that is collapse point. And the last table, as you can see, a few largest participant factor for the critical in value. So the main cause of the incident is, the first one is the distance relay protection system is designed to detect fault in a transmission line by measuring the impedance or distance to the fault location. In this case, the lightning strike caused the fault on one of the line and the distance relay protection operate as intended, tripping the affected line. However, due to the close proximity of the lightning strike and the associated fault, the protection system respond rapidly, causing the second line to trip as well. Second, the simultaneous tripping of both lines resulted in a significant power deficit as they were responsible for transporting about 500 megawatt of power to the Colombo area. This deficit, coupled with a cascade effect of load tripping, lead to a complete blackout in the system. Therefore, the main or the root cause of the incident can be attributed to the lightning strike, which caused the tripping of the Mel Biagama line. The operation of the distant relay protection system intended to protect the system from fault responded to the fault triggered by the lightning strike. However, the rapid response and subsequent tripping of both lines resulted in the blackout.
So the impact consequences of the impact or consequence of the incident to the engineering and society aspect. So from an engineering perspective, first, the system disruption. The incident resulted in a total blackout, causing a disruption in the power supply to the affected areas. This not only inconvenienced consumer but also impacted critical service and industry that rely on a continuous and reliable power supply. Second is equipment damage. The cascade tripping of loads and the subsequent restoration efforts can lead to equipment damage and failures within the power system. This can result in financial losses due to the needs for repair or replacement of damaged equipment. So, and the third one is system reliability concerns. The incident raised concerns about the reliability of the Sri Lankan power system. It highlighted the vulnerabilities and potential weaknesses that needed to be addressed to enhance the resilience and stability of the system.
The impact of the incident to the engineering to the society aspect. The first one, economic impact. So the blackout causes caused by the incident had a significant economic impact on the country. Productivity and business operation were disrupted, leading to financial losses for individual companies and overall economy. They estimate total loss of 851.9 megawatt hour further underscores the economic consequences of the incidents. The second one, public safety and well-being. So power outage can have serious implications for public safety and well-being. Critical service such as healthcare facilities, transportation system, and emergency response system rely heavily on a reliable power supply. The incident may have compromised the delivery of essential service and put the safety and well-being of individual at risk. The last one is public perception and confidence. So power system incidents like this can erode public confidence in the reliability and stability of power supply. The incident may have raised concern among the public about the ability of the power system to withstand similar event in the future, impacting trust in the system and its operators.
So, from the incident in the Sri Lankan power system on May 2, 1995, this incident provides us several important lessons. The first one is the importance of lightning protection. The incident highlights the significance of having effective lightning protection measures in place. Lightning strike can cause significant damage to power system, leading to equipment failures and blackout. So, adequate lightning protection system and strategies should be implemented to minimize the impact of such as incidents.
Now I will explain the second of important lesson, which is reliability of protection system. The incident emphasized the critical role of protection system in maintaining the stability and reliability of the power system. The distance relay protection system operate as intended to detect and respond to the fault caused by the lightning strike. However, the rapid response and subsequent tripping of both lines resulted in an unintended consequence, highlighting the need of careful coordination and analysis of protection system setting.
Okay, for the last lesson, uh, importance of system resilience. The incident underscore the importance of system resilience and the ability to quickly restore power after a major disturbance. The restoration effort were able to bring the system back with a reasonable time frame, demonstrating the importance of having contingency plan, backup system, and efficiency restoration procedures in a place to minimize the duration and impact of blackout. So that we all can conclude, the incident served as a reminder of the importance of proactive measure, system resilience, and the continuous learning to ensure the safe and reliable operation of power system. It reinforced the need of efficient protection system, lightning protection measure, and comprehensive planning and operation strategy to mitigate risk and minimize the impact of incident on power supply and consumer. That's all from our group. Thank you.